special factoring forms. So there are a couple of shortcuts that will hopefully make this whole process a little bit easier for you. We've already discussed both of these, and we've already actually worked with them both quite a lot, so I'm hoping this will be a review for everybody. Now, we've been working a lot with perfect square trinomials. For example, in this expression, we have x squared plus 16x, and we need to figure out how many more we need to add in order to make this a perfect square. And as we've been doing for the past several weeks, we're going to take that middle number, 16, we're going to divide it by 2, and we're going to square it. Well, 16 divided by 2 is 8. 8 squared is 64. So by now you should have a pretty reasonable grasp of what is and is not a perfect square trinomial, and that means if you recognize them out there in your exams or in your homework assignments, you'll be able to utilize this knowledge. For example, if I have x squared plus 12x plus 36, and I'm told to factor completely, well, I could go about dividing 36 into two factors and trying to figure out what's what, or I could recognize that this is, in fact, x plus 6 squared. I could tell right away that if I take that 12, divide it by 2 to get 6, and square it, that gives me 36. No real math needed. In general, our formula goes something like this. A plus b squared equals a squared plus 2ab plus b squared. And again, that should really make sense because you're dividing by 2 and squaring to get that last number. So here's an example. X squared minus 16x plus 64. So again, we could go about all the hassle of trying to figure out two numbers that multiply to make 64 and add to make negative 16, or we could recognize that negative 16 divided by 2 and then squared is indeed 64. Negative 16 divided by 2 is negative 8, then squared is 64. We have a perfect square here. We don't have to do any more math. That's all there is to it. Let's do another one. Let's do a more difficult one. How about something crazy like 25n squared minus 30n plus 9? Now, we've never even seen anything like this before. It looks completely bonkers, but if you look at the two outsides, you can see that they're both perfect squares. So this could be a perfect square trinomial. If it is, A would be 5n and B would be negative 3, right? Because 5n squared is 25n squared, and negative 3 squared would be positive 9, and 2 times A times B does indeed equal negative 30. Our answer is 5n minus 3 squared. Now that one we totally could have solved the usual way that I taught you a couple of videos ago, but this is another good way of going about it. Let's try one more example. We have 100x squared minus 40x plus 4. Okay, first step here. Well, I do see a couple of things I can do right now. First off, step 1, every single time, is there a GCF? Now, we haven't actually asked that question in the last couple of examples, so shame on me for not doing that. I do see that all of this is divisible by 4. 100x squared divided by 4 is 25x squared. Negative 40x divided by 4 is negative 10x. And then 4 divided by 4 is positive 1. Okay, once again, we could multiply a times c to get 25, try to figure out two numbers that multiply to make that and add to make -10. That would work just fine, but we could also recognize the perfect square nature of what we've got here. And if this is that perfect square, then a would be the square root of 25x squared, which is 5x, and b would be the square root of 1, which is 1. So the only question is, does the middle term match? Well, let's find out. 2 times 5x times 1. Well, that doesn't seem right. That would give me positive 10x. That doesn't seem right at all. Oh, I see what I did wrong. This b must have been -1. Because then I would have 2 times 5 times -1 equals -10x. Okay, so I was slightly off, but still, my final answer is going to be 4 times 5x minus 1 squared. So that's the first special factoring form, the perfect square trinomial. Again, even if you don't have like a perfect understanding of all of the notation involved, you've been working with these perfect squares for some time. So if you recognize that something that you're working with is a perfect square, you are allowed to use that knowledge. Just write down that it's a perfect square, and that will count as justification. All right, we're going to look at another special form that pops up all the time that, again, a lot of you have been seeing a lot of. We call this one the difference of two squares, and it again is something that we've seen before, but I kind of want to have it set down for you so that you can look at this video at any time and remind yourself of what it is. It looked something like this. Just like when you had the perfect square, if I had a perfect square a plus b times a plus b, right? We got a squared plus ab plus ab plus b squared, right? This is where the 2ab comes from. Again, first, outside, inside, last. Okay, so it's slightly a different story if you have a plus b times a minus b. Same values of the two numbers, only one plus in the middle and one minus. In this case, the positive ab and the negative ab cancel out. So we still have the a squared and we still have the b squared. It's just that that plus ab and that minus ab canceled out. So the final form of this particular formula is a plus b times a minus b equals a squared minus b squared. And it doesn't seem like much, but again, you can use this to help you save a lot of time if you recognize it during factoring problems. Let's do an example. We'll start with an easy one. X squared minus 36. Pretty clearly, both of those are perfect squares. The answer is x plus 6 times x minus 6. The square root of x squared is x. The square root of 36 is 6. So you end up with a plus b, x plus 6, times a minus b, x minus 6. Let's do another example. Now, because there's a number other than 1 in front of the x squared, we should figure out whether there's a factor that we can divide both of these terms by, and it turns out the answer is yes. They're both divisible by 2. So 2x squared divided by 2 is just x squared. Negative 18 divided by 2 is negative 9. Now we're not quite done yet because x squared and 9 are both perfect squares. So we have ourselves a difference of squares here. So our final answer is 2 times x plus 3 times x minus 3. No problem. Let's do another one. 9x squared minus 1. Well, again, we have two perfect squares, right? 9x squared is the square of 3x, and 1 is the square of 1. 1 is very convenient that way. So I can break this up into 3x plus 1 times 3x minus 1. As you can see, once you start figuring out this pattern, the problems almost solve themselves. Example 4, and this is the last one for today. What if I have something crazy like 49x squared minus 25y squared? We've never dealt with anything like this before. We've never put y's in here. We've never had multiple variables going on at once. What are we even doing? But it's still a difference of two squares, so it still follows the same rules, the same logic. 49 is 7 squared. 25 is 5 squared. So we can break this down into 7x plus 5y times 7x minus 5y. Happy face. We got this. Now, except for maybe that last one, each of those is probably doable just by looking at our normal everyday factoring method. The thing that I taught you in the very first video that I released, you should be able to use to solve most of these. What I'm trying to do is I'm trying to save you time and I'm trying to save you energy.